So now let's do a quick practice question applying some of these concepts. So this one says uranium-238 decays to lead-206 through a series of radioactive transformations. How many alpha and beta minus decays occur in the radioactive decay series from uranium-238 to lead-206? And here I've included the atomic symbols for the uranium and the lead, right? And remember, the top number is going to be the mass number, okay, so 238 to 206, and then the bottom number is the atomic number, so from 92 to 82. So let's summarize what's happening in terms of the mass numbers and the atomic numbers, right? So the delta, or the change in the mass number, A, is going to be 238 minus 206, so the final, which is going to be equal to 32. Okay, and then the change in the Z, or the atomic number, is going to be 92 minus 82, which is simply going to be 10. So notice that all the answer choices are some combination of either alpha or of alpha decay and beta minus decay. And what we can do to easily answer this question is recognize that only alpha decay can change the mass number. Beta decay cannot. It doesn't change the mass number at all. So what is the change in mass number, right? Well, it's 32. And remember that alpha decay, right, for each event of an alpha decay, A decreases, the mass number decreases by 4, okay? So to get 32, you need 8 alpha decays, right? Because we just divide 32, the total change in the mass number, by 4, right? The change in the mass number from one alpha decay situation, and that's going to be equal to 8 alpha decay or decays, right? So for every single alpha decay event, what is the change in the atomic number, right? Well, for 8 alpha decays, remember that there's a decrease in 2 protons every single time. So you would expect to lose Z minus 16 protons, okay, for 8 alpha decays, right? So for one thing, we know that there needs to be 8 alpha decays, so B already has to be correct, okay? But why do we need the 6 beta decays? Well, remember that the net decrease in the atomic number is 10. So there's a net loss of 10 protons, but for the 8 alpha decay events, there's a loss of 16 protons. So how do you get those 6 protons back? Well, you have 6 beta minus decay events, right? Which leads to the atomic number increasing by 6. So then you lose 16 protons due to the alpha decays and gain 6 back from the beta minus decay, and so your net loss is 10 protons.